Hello guys, welcome to another video. This one is paper 2-2 of May-June 2014 for Add Math. So with that being said, let's move on to question number 1. So without using a calculator, express this expression in the form of a plus b root 5, where a and b are constants to be found. So now, when they ask not to use a calculator, in reality, you can use one. No one is watching you. You just have to show every step of your work of how did you find the answer. So let's do that one by one. So on the numerator, we have this value. Let's expand and see what happens. So we have 2 plus root 5 squared. So if you expand, you will have what? 4 plus 4 root 5 and plus 5, which is 9 plus 4 root 5. Now let's replace this back in the main fraction. So right now you will have on top is 9 plus 4 root 5 over root 5 minus 1. So now we have to simplify this, so we have to multiply the top and bottom by the conjugate of the denominator. So doing this and this. So let's do one by one. So for the base, it's pretty easy. You will have root 5 minus 1 times root 5 plus 1. For the top, let's do one by one. So first take 9. 9 multiplied by this, you will have 9 root 5 for the first one plus 9. And then for this one, you will have 4 root 5 times root 5 is 4 times 5, because root 5 times root 5 is 5, times 4 is 20. So you have to plus 20. And then finally plus 4 root 5, right? That will be the simplification. Now let's see what else we can do. So here we have 9 plus this, that will be 29. And here we have 9 plus 4 will be 13 root 5. So for this, we can simplify this. If you observe, you don't have to know this, but it is always best if you know this shortcut. Because if you observe, this is a minus b, and this is a plus b. So this will give you the difference of the squares. So same thing, you will have a as root 5, which is 5, minus 1, that should be 4. So your base will be 4 right here. And then we can just simplify. You will have 29 over 4 plus 13 over 4 root 5. This is expressed in this form where a and b are constants to be found. Okay, so that will be your question number 1. Now let's move on to question number 2. So here we have to find the values of k for which the line is a tangent to the curve. Now what does that mean? Tangent means the line meets the curve at only one point. So now if they meet at only one point, we can know that b squared minus 4ac has to be 0. That's what we know from that information. Now since they meet, we have to solve simultaneous equations for the line and the curve. So here we have y. Let's make this become subject of formula. You will have y is equal to 2 minus kx. Now replace in the main equation. So on one side you will have 2 minus kx is equal to 2x squared minus 9x plus 4. Simplify, let's send everything to one side. You will have 2x squared minus 9x plus kx plus 4 minus 2 is 0. Simplify, 2x squared, this will become, so we factorize the x outside, so let's take out the value of plus x outside. You will have minus 9 plus k. And then 4 minus 2 is 2 equal to 0. Now let's rearrange this so we can form our equation. So that will be 2x squared plus, so this can be written as k minus 9 x and plus 2 equal to 0. As you can see right now, we have a quadratic equation. This is a, this is b, and this is c. So we know that because they meet at only one point, we can use this formula. The discriminant has to be equal to 0. So b square will be what? K minus 9 square minus 4 times a n times c equal to 0. Let's solve. That will give you k minus 9 square minus 16 equal to 0. So simplify. K minus 9 square will be 16. Okay. Now let's continue on this side. So k minus 9 can be two answers. Can be plus minus root of 16, which is plus minus 4. Now k minus 9 can be minus 4. K minus 9 can be plus 4. K can be minus 4 plus 9. K can be 4 plus 9. So k can be 5 or k can be 13 for your answer. So find the values of k. So the two values will be 5 or 13 for question number 2. Now let's move on to question number 3. So given that x plus 1 is a factor of that expression, show the value of d equal to this. So because it is a factor, we can use our remainder theorem. For example, I can first say let f of x equal to the expression that we are given. So that's my first step. And then because I know we know that x plus 1 is a factor, let's equate that to 0 so we can find the value of x will be minus 1. So it means if my function takes the value of minus 1, it should give me the value of 0. This is called the remainder theorem, because since it is a factor, the remainder should be 0. So x equal to minus 1 in your equation should give you the value of 0. So let's do that. That will be 3 minus 1 cubed minus 14 times minus 1 square minus 7 times minus 1 plus d has to be 0. So simplify, this will be minus 3 minus 14 plus 7 plus d has to be 0. That will be minus 10 plus d has to be 0. So finally, d has to be 10 as your answer shown as required. That is part A. Now for part B, we have to show that this expression can be written as this form, where a and b are constants to be found. So basically we have to factorize the expression. So we know the factor, we have to do the long division in this case. So let's do that. 3x cubed minus 14x squared minus 7x plus 10. We have to do the long division with the factor of x plus 1, because we know they are factors already. Now first thing first, how can you make x become 3x cubed? You have to multiply by 3x squared, right? So you will have 3x cubed. 1 times this will be plus 3x squared. So now we can simplify, this will go away. Minus 14 minus 3 should be minus 17x squared minus 7x plus 10. So now, how can you make x become minus 17x squared? So to multiply by minus 17x, right? So you will have minus 17x squared, and then 1 times this will be minus 17x. So simplify, this will go away. Now minus 7 minus minus 17 should be 10x plus 10. Now how can you make x become 10x? Have to multiply by plus 10. So you will have 10x plus 10. That will be 0. So here you go. Finally, we realized that the function can be written as x plus 1 multiplied by this quotient. That will be 17x plus 10 as the value of a, b, and c. Okay, that will be part 2 of the question. Now for part 3, hence solve the equation. So pretty easy. Hence, whenever you see hence, you have to use your previous answer. Solving this, because we know this can be written as this already, let's just do that. So we can solve the equation. So you will have this plus 10 equal to 0. Now let's try to factorize the other part of the equation. So here we have 3x squared which is 3x times x. And here we have 10. 10, what is 10? 10 is 2 times 5. So let's put 5 here and 2 here. The reason why is because we want to get minus 17. So 3x times minus 5, that will be minus 15. Minus 2x, that will give you minus 17. So this is the complete factorization of this expression. Now equal to 0, we can find the values of x. X will be minus 1. X will be 2 over 3. X will be 5. So these will be the solutions of that equation. Now let's move on to question number 4. Express this in the form of this, okay, where p, q, and r are constants to be found. So as you can see, it is complete square form. So the first thing, as I have explained before many times, when we have this quadratic equation, we have to make sure that the coefficient of x squared is always 1. So let me do something first. I will write 12 x squared minus 6x, some space, plus 5. Now, I have to make sure to make this become 1. So let's factorize 12 outside. That will become x squared minus 1 over 2x, right? Because if you take out 12, so 6 divided by 12, it is half. Okay, so you will have this on the inside plus 5. So now we can complete square for this part. So let's do that. So that will be 12. We have x squared. Here we have minus 12 for now. So now we have to add something. We have to add the number here. So we don't take into account the sign, just the value here, which is half. And then divide by 2 square. Now when you add something, you have to minus the same value. That will be half over 2 square. Because it was inside the bracket, we also have to take out the value of 12. Okay, so this is the main expression now, so we have to simplify. That will be 12. And here we have x, we write x. Here we have minus, we write minus. And here we have this value. So what is that value? Let's check. Half divided by 2, that should be 1 over 4. But let's check. Half divided by 2, 1 over 4. That will be 1 over 4. And here we have square, that will be square. Here we have to simplify. We have 5 minus 12 times 1 over 4 square. Because this value inside is 1 over 4 square. That will be plus 4, 1 over 4. Okay? So that will be your expression. Let me write this down again. So finally, we have realized that this can be written as, we take 12 outside. That will be x minus 1 over 4 square plus, if you want to expand this, you can always do that. That will be what? 4 times 4 is 16. 16 plus 1 is 17. 17 over 4. Or you can write, it is up to you, you can write 4.25. Because if you observe, this is 4.25, right? So this will be your answer for part 1. Okay? Now let's move on to part 2 of the question. So here we have to find the greatest value of this expression and state the value of x at which it occurs. So how can you find the greatest value of 1 divided by this expression? So now we observe, when the question is asking you we see hence. Whenever you see hence, what do? We have to use the previous answer. So previously we had what? We had changed this into 12 minus 1 over 4 square plus 4.25. Now, when we complete square forms, we have to know a few things. The minimum point will be this value equate to 0. And this is the minimum value that you will have. So we have to recall, whenever we are able to express our function in this form, we use the inside value to find the x value of the minimum point, and the value in the end will be your minimum value. So how do I know it is a minimum value? Very simple. It's because the coefficient of x squared is 12, which is a positive value. So whenever you have a positive value as the coefficient, the curve will look something like this. So we know this already, right? So the point here is, we understand that to find the biggest value of 1 divided by something, we have to divide by the smallest value of the curve. And as we have seen, the smallest value of the curve is 4.25. That's the minimum value of our function. So 1 divided by 4.25, that will be 4 over 17 will be the greatest value of that expression. Now state the value of x at which this occurs. So it occurs at, look at the value inside the bracket, it is x minus 1 over 4. We just have to equate that to 0. X will be 1 over 4. So it occurs at x equal to 1 over 4. We have this value of this expression. Okay, so that will be question number 4. Now let's move on to question number 5. So find and simplify the first 3 terms of the expansion in ascending powers of x. So the first 3 terms of the expansion. So let's do one by one. So we have 1 minus 4x power 5. We have 5, choose 0 first. So we take 1 and minus 4x. This is 0, this will be 0. 5 minus 0 is 5. Second term, 5 choose 1, that will be 1 and minus 4. That will be 1 here, and that should be 4 here. Afterwards, 5 choose 2, that will be 1 minus 4x. This will be 2, this will be 2 here, and that will be 3. So we need just to stop right here because we just need the first 3 terms of this expansion. Now 5 choose 0 is 1, 1, and that is 1. Plus 5 choose 1 is 5, 1 and minus 4x. 5 choose 2 is 10, but let's check. 5 choose 2 is 10. That will be 1 and that will be 16x squared. So that will be 1 plus minus 20x plus 160x squared. So finally, that will give you 1 minus 20x plus 160x squared. That will be your answer for part 1 of the question, the first 3 terms of the expansion. Now for part 2, the first 3 terms of the expansion, okay, of this expansion now, so we have a new expansion, are given to be those 3 numbers. So we have to find the value of a and b. So at first, what can we do is, let's pretend to expand this to expression. So we know this answer from part 1, it was given by 1 minus 20x plus 160x squared, multiplied by 1 plus ax plus bx squared. So now if you look at this, we only care about the term up until x squared. So let's only find that in the expansion. So 1 times this will give you 1 plus ax plus bx squared. Now minus 20 times this will give you minus 20x minus 20 ax squared. So I will stop right here because if I multiply this and this, that will give me something in x cubed, and we don't need x cubed, so we can stop right here. Now for this one, we can just multiply the first one, 160 x squared, because the rest will be not relevant. Now we can simplify this. So 1 is 1, right? So how about the rest? So here we have something in x, here we have something in x, we can combine those two together. That will become a minus 20 x. Now we have something in x squared, and x squared. That will be b minus 20a plus 160 x squared. So factorize. So now we just have to compare the coefficients to find the value of a, b, and c. So we know that this is supposed to be this is 1, this is minus 23, and this is plus 2, 2, 2. So we just have to compare. For example, I can see that this is a minus 20 is supposed to be minus 23. So which means a has to be minus 3, right? Now for this one, b minus 20a plus 160 is supposed to be 2, 2, 2. So let's simplify. b has to be 2, 2, 2 minus 160 plus 20a is minus 3. So simplify. 2, 2, 2 minus 160 and minus 16. That will be 2. So b will be the value of 2. So we conclude that a is minus 3 and b has to be 2. This is the values that we need for question number 5. So let's move on to question number 6. State the value of u for which log of u is equal to 0. So first thing first, we have to know what is log. It is actually log to the base of 10. So right now we have log to the base of 10 u is equal to 0. So which means u has to be 10 power 0, which is 1. That is my value for part 1. Now for part 2, hence, we have to solve this equation. Hence mean we have to use that value. So we have log base of 10 modulus 3 equal to 0. So now we know that this, if you send this here, will become 2x plus 3. That will be 1. Now we can solve this. There's many ways. There's 2 ways to solve this. We can square both sides and solve. What you can do is you can just write the left hand side because of the modulus. You can write equal to 1, or you can write 2x plus 3 equal to minus 1. That is one of the ways we can solve it. But now if you want to, you can just square both sides and solve step by step. That will be 2x is minus 2, x will be minus 1. 2x will be minus 4, x will be minus 2. That will be the 2 values that we get for part 2. Now for part B, we have to express this expression where a is a positive value as a single logarithms to the base of 3. So we have to combine these 3 terms together. So let's see how can we do that. So first thing, we have 2 log to the base of 3, 15. So we can write this as log to the base of 3, 15 square, which is log base of 3. 15 square is what? It is 225. So 225. That is this one. Now for the rest, let's have a look one by one. So here we have log base of 3a. So this will not move. It will be the same thing because it is already with a base of 3. Now how about this one? Log of a to the base of 5, to the value of 5. So we have to know this rule of logarithms so we can solve this. So basically, we have to take log to the base of 3 and log to the base of 3 on the top and bottom value. Now this will be 5 here, and this will be a here. Okay, so now we have to replace this one back in the main equation. So let's do that. So right now you will have on one side, you will have log 225 minus, that will be log base of 3, 5, over log base of 3a multiplied by log base of 3a. And if you observe, these two are the same, so they will cancel out. Okay, and this you will have remaining, which is log to the base of 3, 225 minus log to the base of 3, 5. So we can simplify this because they have the same base. That will be log to the base of 3, 225, and because we have minus here, that will become divide by 5. That will give you 45. So your answer will be base of 3, 45. That will be your answer for part B of the question. So the main point here is you have to know how to do this. For example, if I have log base of a value b, if I want to express this as log to the base of c, for example, we can write this down as log, first let c, and log base of c. Then we take the first value, b, and this value, a. So this is equal to this if you want to change the base of your logarithms. In this case, this is what we did to change the base to base 3. That will be this, and replace back in your main equation, and then simplify, you will have this as your value. Now let's move on to question number 7. So here we have to differentiate with respect to x. So for the first one, as you can see, it is a product, so we have to use the product rule. So d by dx will be what? So will be uv prime plus v u prime. So this is my u, this is my v, so let's replace. U is the same, x power 4, v prime will be 3 exponential 3x, plus v is exponential power, so 3x, and then u prime will be times 4x power 3. So simplify, you will have 3x power 4 exponential this, and then 4x power 3 exponential this. This will be your answer for part 1. Now for part 2, we have to differentiate this one, so let's do one by one. So let's first think, how do we differentiate? For example, you have ln of 2x. How would you differentiate this? So you will do what? You will do 1 over the value of the inside, then multiply by d by dx of the value inside. So that will give you 2x, so 2 over 2x, which is 1 over x. For example, right? Now same thing here, we will get d by dx will be what? 1 over the value inside, which is 2, plus cos x multiplied by d by dx of the value inside. So let's see, what do we get? That will become, so this is 0, this will become minus sin x over 2 plus cos x. That will be part 2 of the question. So that's the idea, you have to know how to do this. Now for part 3, we have to differentiate this one. So if you observe, this one is a fraction, so you have to use your quotient rule. So let's do that. So d by dx will be what? First we have to write the denominator as it is, so 1 plus this. Then d by dx of the first one will be cos x. Then we have minus. Then we write the first one as it is. And then d by dx of this one. So this one is tricky. We have to write this down again as 1 plus x power half. So that will give you half x power minus half. Then of course everything divided by the denominator square. That is, how would you find this? Now we have to simplify this one. So that will be cos x, 1 plus root x, that will be minus sin x over 2 root x, and then everything divided by 1 plus root x square. So now I will just stop right here, because there's no need to simplify more. If you want to, you can do that, it is up to you, but it is enough for your answer. That will be question number 7. Now let's move on to question number 8. So we have a line y equal to x minus 5, meets the curve. This is a long curve. At the points A and B, find the exact length of A and B. So basically, if it meets, you see meets, whenever you have the word meets, intersects, cuts, we have to solve the simultaneous equation. So here we have y. Let's replace this in the equation of the curve. That will be x squared plus y squared will be x minus 5 squared plus 2x minus 35 equal to 0. So simplify, that will become what? X squared plus x squared minus 10x plus 25 plus 2x minus 35 equal to 0. Now if you add those two, that will be 2x squared minus 10 plus 2 will be minus 8x. This minus this will be minus 10 equal to 0. Now we can simplify these two, so this equation, by dividing by 2 everywhere. Because they are all even numbers, we can divide by 2 everywhere. You will have x squared minus 4x minus 5 is equal to 0. So now we can factorize. What is x squared? It is x times x, and 5 is 5 times 1. For you to get minus 4, you have to have minus 5 plus 1. Okay, so x will be minus 1, and x will be the value of 5. So now we know the values of x, we have to find the corresponding value of y from the equation of the line. So we know the line is y equal to x minus 5. So let's find the corresponding value of y. So when x equal to minus 1, y will be minus 1 minus 5, which is minus 6. When x equal to 5, y will be 5 minus 5, that will be 0. So the point A will be -1, -6, and the point B will be 5, 0. Okay, so now sometimes I do get a question is, let's say I have those 2 points. I have -1, -6, and I have the point 5, 0. So the question is, why this one is not A and this one is B? So because if you observe, for the x value, here we have -1 and here we have 5. So which one comes first? So obviously -1 comes before 5, right? So in the same way, in the alphabets, A comes before B. So that's why we have to put A for the first one and B for the other one. So this will be your answer. So this is just a side note for you, for those of you who are confused by why this is not, can be the other way around. So it is because of the order of letters and numbers. That will be the 2 points. Now we have to find the exact length of AB. So there's many ways of doing that. You can just use your formula. That will be, so we can take x2 minus x1, that will be 6 squared, and y2 minus this, that will be also 6 squared. That will be 36 plus 36, that will be what? 72. So 72, that will be the exact value of the length of AB. So this is the exact value, root of 72 for this one. So the formula again, let me write this down. It will be what? It will be square root of the value of x2 minus x1 square and y2 minus y1 square. This is the formula for length between 2 points. This is what I've used here to find this value. That will be question number 8. Okay, so now let's move on to question number 9. We have a curve is such that dy by dx is given by this. The curve passes through the point. This is x and y, right? Now we have to find the equation of the curve. So now when you have to find the equation of the curve, it is asking you to find y. So how do you find y from dy by dx? You have to find by integration. So this is something you'd have to know. Y is equal to integration of dy by dx with respect to x, obviously. So let's do that. Y will be, that will be 2x plus 1 half dx. So that will be, first thing we have to increase the power by 1, that will be 3 over 2, and then divide by the power, and then divide by the differentiation of the inside of the bracket. So what is d by dx of the inside of the bracket, which is this value? That will be 2, so divide by 2. Of course, we have to write plus c as your constant of integration. So these two will cancel out, as you can see here. And then what do we have? So right now we have y is equal to 2x plus 1, 3 over 2 over 3 plus c. So we have to find this value of c. So now to find this value of c, we have to use the given values of x and y to find that. X is 4, 1, y is 10. So 10, that will be 2x is 4 plus 1, 3 over 2 over 3 plus c. So let's continue here. What is this value? That will be 9 power. So 2 times 4 is 8, plus 1 is 9, 9 power, 3 over 2. That will be this, divided by 3, that will be 9. So that will be 10 equal to 9 plus c. So c will be 1. So finally, y will be 2x plus 1 power 3 over 2 over 3 plus the value of 1. So this is part 1 of your question. Now for part 2, find this. Hence, we have to find this one. So y has been given to you. So now you know what is y from part 1. It is 1 over 3, 2x plus 1, power 3 over 2, plus 1. So we have to integrate y again, which is 1 over 3. That will be 2x plus 1, 3 over 2, plus 1 dx. So one by one, let's do that. So 1 over 3, we can just take this out, we don't care. And then we have to first increase the power by 1. So 3 over 2 plus 1 is 5 over 2. Then divide by the power. Then divide by the d by dx of the value inside, that will be 2. Then plus 1, that will be x, and plus c, right, for the, or plus d, because c we have used c already, and plus d for the constant of integration. Let's simplify. So this will give you what? So this will cancel out. So you have 1. 3 times 5 is 15. That will be 2x plus 1, 5 over 2, plus x plus d for the first part of your, for this part of your question. Now, hence evaluate this, we have to put limits on this integration. So this will be 1.5 and 0 y dx. That will be 1 over this times 2x plus 1, 5 over 2 plus x. So here we don't need d because we have the limits of integration. So now replace 1 by 1, that will give you what? 1 over 15, that will be 2 times 1.5 is 3 plus 1 is 4. That will be 5 over 2 plus 1.5, and then minus, that will be 1 over 15, that will be 0, 1, 5 over 2 plus 0. So let's simplify. That will be what? 4 power 5 over 2. That will be 512 divided by 15. That will be 34, 2 over 15, plus 1.5 and minus 1 over 15. So let's see what do we get. So this minus 1.5 and minus 1 over 15. That will give you 32, 17 over 30 as the exact value of that integration. So as always, we always proceed step by step. That will be your question number 9. Okay, so let's move on to question number 10. So here we have two variables, x and y are connected by this equation. So first thing first, we have to transform the equation into a straight line. So what do we know about straight line? We know the equation looks like this. Y equals to mx plus c, which is the constant. So we just have to change that into that. So let's take log on both sides. So we can take ln or you can take lg. But since I can see they have shown ln here, let me just take ln on both sides. So ln of y and ln on a b power x. That will be ln of y is equal to ln of a plus ln of bx. Of y, that will be, so we can send the power down, that will become x, ln of b plus ln of a. So finally, that will be what? ln of b bracket x plus ln of a. As you can see, this looks a lot like a straight line equation. This is your y-axis, for example. This will be my gradient. This is my x value, and this is my y-intercept. Now for part 2, an experiment was carried out measuring values of y for certain values of x. Okay, the values of ln y and x were plotted, and a line of best fit was drawn. Okay, the graph is shown on the grid below. Okay, as you can see, we have the results on the graph. Now part 2, use the graph to determine the value of A and the value of B. Give your answer correct to one significant figure. So now, we have to use the graph, but also we have to look at our main equation. So the equation that we have received is ln y is equal to ln b of x plus ln of A. So, as we have explained, this value here will be the gradient, right? M. And this value here will be the y-intercept. So pretty easy. Let's look where the curve cuts my y-intercept. As you can see, the value is here. This is the value of what? This is 1, 2, and 3, which is 0.6. So as we have seen, the ln A has to be 0.6. Okay? because of that. So if you want to, let's do something more easy for you. Let's first find this point. What is this point? You will say the point is what? It is 0. It is minus 0.6. That's the value, not 0.6, minus 0.6. Okay, so that's the value. So this is x, obviously, because this is x, and this value will be ln y. Now let's replace these two values back in our main equation. So what you will have? You will have minus 0.6, right, equal to ln b times x, which is 0, plus ln a. So finally, you will have ln a is going to be minus 0.6. So a will have to be exponential power 0.6. That will be 0.5, correct, to one significant figure. So a will be 0.5. Now to find the value of b, if you observe, as we have said before, ln of b is the gradient of that line. So let's first find the gradient. Let's use the 2 points. The first point we have is what? Let's use the graph. So from what I can see, I can use any point on the line. You can choose anything that you want to. It is up to you to choose those values. So I will choose this value first here. If I want to choose this one, this is my point 1, and then I have the point here is what? It is 0.2, 0.4, 0.6, 0.7. That's my first point. And now I'll choose this point. This is 3. And this will be 3.4. So now I have 2 points. I can find my gradient of the line. So the gradient will be simply y2 minus y1. So 33.4 minus this divided by 3 minus 1. That will be 1.35. So as we have compared before, from here, we said ln of b is the gradient, which is 1.35. So b has to be exponential 1.35, because we know that ln is actually log to the base of b. That's why we have this. So exponential 1.35, that should be 3.857, but to 1 SF, that will be 4. Okay, so by conclusion, we have the value of a, which is 0.5, and b, which is 4, to 1 SF. Now for part 3, we have to find the value of x when y is equal to this. So let's use our equation. So right now we have ln of y is equal to ln of b is 1.35, x plus ln of a is minus 0.6, as we have seen on this before, right? So this is our equation right now. So we have to find the value of x when y equal to this. So ln of y is 220, 1.35x minus 0.6. So 1.35x will be what? Ln of 220 plus 0.6. That will be 5.99. X will be divided by 1.35. That will be 4.44. That's my value for x, correct to 3SF. Okay, that will be question number 10. Okay, so let's move on to question number 11. The functions f and g are defined for real values of x bigger than 2, okay, more than 2, by those two equations. So this is important here, more than 2. So for part 1, state the range of f of x. So to find the range, usually we have to look at the graph, or we can just simply have a look at our domain. So define for x more than 2. So first let's assume what value do we have? So let's say we have f of 2. Well, we have 2 power 2 minus 1. That will be 4 minus 1, and that will be 3. Okay? So we know that. So from this we can know that it will begin from the value of 3. But it will not equal to 3 because your value, it is not equal to 2, it is more than 2. So the idea here is that if you were to draw a graph for f of x, the graph will begin somewhere here at x equal to 2, it will begin at the value of 3, but 3 is not included. As you can see, you will keep going up, right? So by looking at the graph, you can see that the range of f, so f, you can see, you can write f or you can write y, has to be more than the value of 3, right? As you can see, according to the graph, because from that value, your curve keep going up. Because as you can see, here we have 2 power x. As we increase the value of x, the graph will keep going up, right? That's why we conclude it will be in this shape, and the range is the y values. As you can see, it would begin here, not including 3, but it will keep going up, so the range will be more than 3. Now for part 2, we have to find an expression for f inverse, and then we have to find its domain and the range of that. So let's do that. It's pretty easy. So first is to let y equal to f of x. That will be 2 power x minus 1. Now you will have 2 power x, that will be y plus 1. Now we can take ln or log, it is up to you. So I will take ln, why not? Take ln on both sides. Okay, so you'll have this for now. Now you can bring this power down, that will become x ln of 2, x plus 1, then finally x has to be ln of x plus 1 over ln of 2. Okay, so now we have to write, obviously, f inverse, it is in terms of x, that will be ln x plus 1 over ln of 2. Ln of 2 is just a constant, we don't really care, but that is your equation for f inverse. Now we have to write its domain and the range, so we have to know something here. The range of f inverse is equal to the domain of f of x. That's a trick we have to know. It helps us to find the values really easily. So the domain of f of x is what? As you can see, it was defined here for values more than 2. So the domain of f of x was more than 2. But here we have to find the range. The range is written as y or as f. So we have to write f is more than 2. That is the first part. Now the same logic here. To find the domain of f inverse of x, it is equal to the range of f of x. So as we have seen before here, the range of f of x was f is more than 3. So as you have seen here, f has to be more than 3. Because it is a domain here, we have to write x is more than 3. Not 0, sorry. I said 3, why did I write 0? No idea. But that should be the corresponding values for the range and domain. So the idea you have to always remember, when they ask you for domain, they are asking you for the x values and the range is the y values. You can write y or you can write f for the domain, but for the range. Domain is always x. That's why it was domain of f is x, but the range is f, or you can write y, and the range is f, the domain is x. Domain is x, range is y or f. Okay, that will be 11 of part 2. Now let's move on to part 3 of the question. So we have to find g f of x. So first let's write down, we have f of x is equal to 2 power x minus 1, and g of x is equal to x times x plus 1. So first let's find g of f of x. That will be, replace x by f of x, that will be f of x, and f of x plus 1. That will be what? F of x is 2 power x minus 1 multiplied by 2 power x minus 1 plus 1. These two will cancel out. So you will have 2 power x times 2 power x and then minus 2 power x. So basically, that will be 2 power x squared minus 2 power x. Okay, so this is the expression that we have for this one. Okay, and explain why this equation will have no solution. So let's see what is that equation. So basically we are trying to say, if you were to solve for this one, you have 2x squared minus 2 power x is equal to 0. So how would you normally solve this? You would try to factorize. You have this, and then you will have this equal to 0. So you would have this one equal to 0, and you will have this one equal to 0, right? So now we have to solve one by one to see what happens. So here you have to take ln on both sides, and here same thing, take ln on both sides. So we have to first send this one over here, so basically 2x will be 1, and you take ln on both sides. Okay, so now what can we do? Let's see. So here, as you can see, what is ln of 0? If you observe, ln of 0 does not exist. So because of that, this part of the solution will be invalid. How about this one? Let's have a look. We have ln this equal to ln of 1. So let's first find the value of x. So x will be here. That will be ln of 2 is equal to ln of 1. So x will be ln of 1 divided by ln of 2. So ln of 1 is divided by ln of 2. So that will not be possible. It will be 0 because this is 0, right? So x will be 0. Now, again, you have to go back to the first part of the question where they tell you that the equations are only defined for x more than 2. But now if you have an answer x equal to 0, clearly if you look at your number line, we have 0 here, we have 1 and 2. So your equation is only defined after this point. So for x value 0 here, it would not be good because it is not defined. So you can write because g of x and f of x is only defined for x more than 2. So for x equal to 0, it will not be valid because of the domain of the two functions. Because of that, we don't have any solutions that we have for that expression. That will be question number 11. Okay, so now let's move on to question number 12. A curve have equation y. So here we have to find the set of values of x for which dy by dx will be more than 0. So let's find out. So first let's find dy by dx. That will be 3x squared minus 18x plus 24 has to be more or equal to 0. So let's simplify the equation first. As you can see, we have 3, 18, 24. They are all multiple of 3, so we can divide by 3 everywhere. You will have x squared minus, that will be what? 6x, and that will be 8 is more equal to 0. Okay, so we have solved this kind of question many times. If you observe, we have to find the critical values first. So critical values, that will be this, and this equate to 0. So factorize, that will be x times x. 8 is 4 times 2. To get minus 6, we have to have minus 4 minus 2. So x will be the value of 4, and x will be the value of 2. But now this is not your answer. You have to look at the graph. So because this is a 1 here, it is positive 1, it will have the shape of this. The first value here is 2. The value here will be 4, and this is 0. Now we want the values of x such that it is more than 0, so we only need more than 0 and more than 0, above 0, right? And that is only defined for x less than 2 or x has to be more than 4. Because we have equal here, we write equal and equal as well. Okay, so basically x, this is your answer, and this will be your answer for the set of values of x for which this is true. Now for part 2, the normal to the curve at the point on the curve, okay, where x equal to 3. So the normal at this point cuts the y-axis at P. Find the equation of the normal and the coordinate of P. So let's do one by one. So normal is a straight line. To find the equation of a straight line, we must first find the gradient of the normal. And now, as always, to find the gradient of the normal, we must first find the gradient of the tangent. And this is equal to dy by dx. So we have to find dy by dx at the value of x equal to 3. So we know this already from part 1. Let's replace the value in this. That will be what? 3 square minus 18 times 3 plus 24. 3 times 9 minus 18 times 3 plus 24. That will be minus 3. So minus 3 will be what? Will be the gradient of the tangent. So from this we can conclude that the gradient of the normal has to be 1 over 3. Because we have this equation, which is gradient of tangent multiplied by gradient of normal have to give you minus 1. So by solving that for this, you will have mn has to be 1 over 3. Now, to find the equation of the normal, we have to find the point, the passing point. We know x is equal to 3, that is the coordinate. We have to find the y value as well. So to find the y value, we have to replace the x value on the curve, which is this one, right? So let's do that. When x equal to 3, what is the value of y? So let's find out. That will be 3 power 3 minus 9, 3 square, plus 24 times 3. That will be 18. So the passing point is 318 for this one. So let's double check because it is not wise to make mistakes in that case. So 3 power 3 will be 27 minus 9 times 9 plus 24 times 3. That should be 18 exactly. Now we have the passing point, we have the gradient, we can find the equation of the normal. So y minus 18 over x minus 3 has to be 1 over 3. Now we just have to cross multiply. You will have 3y minus 48. Well, let's check. 3 times 18, 54. You see, I made a mistake. So we have to always check in exams because you don't want to be too confident. So that will become 3y. That will be x minus 3 plus 54. So let's find this. So that will be minus 3 plus 54. So minus 3 plus 54, that should be 5y. So 3y has to be x plus 51. So this is the equation of the normal. Now we have to find the point P. The point P is where? It is on the y-axis. So what do you know on the y-axis, as we have always done this? On the y-axis, we know at y-axis, what do we know? The value of x has to be 0. So let's replace in your equation. Well, 3y is equal to 0 plus 51. So y will be 51 divided by 3. That will be 17. So 17 will be y. So the point P has to be 0 and 17. Okay, so that will be, I think that's the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.